Hello and welcome to the solution video to my Edexcel practice paper 3. Before watching this video, I'd encourage you to read the disclaimer on the front of the paper. I've put a lot of effort into analysing past papers and of course what topics already came up in paper 1 and paper 2, but this offers no guarantees at all. There are many topics that I couldn't fit into this paper that may well appear, so I'd remind you to revise all topics as technically anything could still be asked. It's definitely better to try the paper before watching this video. You can find a link to the paper in this video's description. Now let's have a look at the solutions. So for question 1, we need to draw a frequency polygon. To do this, we're going to need all of the midpoints. The midpoint of the first group from 0 to 20 is 10. For the next group from 20 to 40, the midpoint is 30. And the remaining midpoints are 50, 70, and 90. We then plot across at each of these midpoints with its frequency. So the first midpoint is 10 with a frequency of 2. So we go to 10 and 2 and plot across. We then do one at 30 with 5, that goes here. One with 50 at 8, that goes here. And then 70, 16 is here. And finally 99, and that goes here. You can then connect up each of these crosses with a straight line, like this. And that's your completed frequency polygon. In this question, we need to work out a calculation. Since you have your calculator, we can just type this straight in. So we begin by pressing the fraction button here, and then we have to type 5.5, multiplied by, and then 10, and then we press this button here to get the power, and it's power 3. Then we press the right arrow because we need to get out of that power, and we're going to add 4.5 times 10 to the power 6 this time. Then we press the down arrow to get to the bottom of the fraction, and it's 1.8 times 10 to the power negative 3. And then we press equals. And our calculator gives us this number here. This question does say though to give your answer in standard form and also correct to 2 significant figures. So the next thing we're going to do is round this answer to 2 significant figures, which should be 2,500,000,000. We now need to write this in standard form. In standard form, the first number needs to be between 1 and 10. So for this number, we would go for 2.5, and then we multiply this by a power of 10. To work out the power of 10, we're going to write out this number and place a decimal point as though the number reads 2.5. We then need to work out how many times we multiply this by 10 to get to 2,500,000,000. So let's multiply it by 10 once, a second time, a third time, a fourth, fifth, sixth, seventh, eighth, and a ninth time. So we needed to multiply by 10 9 times, so it's times 10 to the power 9. In this question, we need to simplify this fraction. Fractions are just divisions, so this is 18a to the power 10, b to the power 15, divide by 6a squared, b to the power negative 3. We'll start with 18 divided by 6, which is 3. Then we need to do a to the 10 divided by a to the 2. Here you can just subtract the indices to get a to the power 8. So it's a to the power 8. And then we also need to divide b to the power 15 by b to the power negative 3. Once again, we subtract these indices, but you need to be careful. 15 subtract negative 3 gives you the same result as if you did 15 plus 3, so 18. So it's b to the power 18. In the second part of the question, we're going to start with what's inside the bracket. When we multiply like this, we add the indices. So 30 plus 5 is 35. So this is 3 to the power 35. But all of that is in a bracket raised to the power 100. When we have a bracket to a power like this, we multiply these indices. So 35 multiplied by 100 is 3,500. So this is 3 to the 3,500. You can see in the question it says 3 to the power k, and we've now got 3 to the power 3,500. So k must be equal to 3,500. For the first part of the question, we're looking for the point that's considered an outlier. A point that's an outlier is generally away from all of the other points that follow a particular trend. So the one that's an outlier for this one is this point down here. It doesn't follow that upward trend of all of the rest of the points. In the second part of the question, we'll need to write down the type of correlation. Since the trend here is in an upwards direction, we would say this is a positive correlation. In the third part of the question, we're told the user is going to upload another video and it receives 300 likes. We need to estimate the number of views that the video received. To do this, we're going to draw a line of best fit, which is a straight line that goes in the direction of the points with roughly the same amount of points above and below the line, so something that looks like this. We then find the point that corresponds to 300 likes, and go across until we hit the line of best fit. When we hit the line of best fit, we then go down to the axis for views, and read off this number. This number is 4.6, but it's not 4.6 views because the axis here is in thousands, so it's 4.6 thousand views, or 4,600. Now you may get a slightly different answer to me for this question depending on how you drew your line of best fit, but you probably should get an answer somewhere in the region of 4,400 to 4,800. In this question, we need to work out the percentage increase in Sammy subscribers between 2022 and 2023. We can see we've been given the number of subscribers for those years up above, 3,200 and 3,700. To find a percentage change, we're going to use this formula. First of all, we need the change, which is the difference between the numbers, so 3,760 subtract 3,200, divide by the original amount, which would be the amount in 2022, so 3,200, and then multiplied by 100. You can just type this straight into your calculator and you'll get the answer 17.5%. In this question, we've been asked to work out the mass of the sphere. We're going to use the formula density equals mass divided by volume, or the rearranged version, mass equals density multiplied by volume. In this question, you can see we've actually been given the density, but we haven't got the volume, so we're going to need to work out the volume using this formula here. For this formula, all we need is the radius, and we've been given the radius at 6 centimeters. So let's work out the volume of the sphere. So the volume will equal 4/3 multiplied by pi, then multiplied by the radius cubed, so 6 cubed. If you type this into your calculator, you'll get this number here. We can now use the formula mass equals density times volume. We know the density from the question, that was 8, and we just worked out the volume, so we just multiply those together. So 8 multiplied by 904.7 and so on. If you type this into your calculator, you get this number here. This question does say to give your answer to 4 significant figures, so if we rounded this off, it would be 7,238. In this question, we're told that the probability of Max completing the first level is 0.4, so we can put that straight onto the tree diagram. The probability that he completes the level is 0.4, so the probability he fails the level must be 1 subtract 0.4, which is 0.6. We are also told the probability he completes the second level is 0.3. So if we do 1 subtract 0.3, we get the probability he fails the level, which is 0.7. In the second part of the question, we need to work out the probability that he does not complete both levels. So we're looking for all of the routes across this diagram where he does not complete both levels. So one way is to complete the first level, but then fail the second level. The probability of this will be those probabilities on the tree diagram multiplied together, so 0.4 times 0.7, which is 0.28. Another way that he could not complete both levels is if he just fails the first level, and then doesn't get to try the second level. This has a probability of 0.6. So we need to add together the probabilities for these two routes, 0.28 plus 0.6, which is 0.88, and the answer to the question. In this question, we need to work out how much butter is needed to make 42 flapjacks. And you can see we've been given the recipe for 12 flapjacks, and the amount of butter we need for those is 125 grams. So what we want to do for this question is divide 42 by 12. This gives us 3.5, and tells us we need to repeat this recipe for 12 flapjacks 3.5 times. If we're going to do this same recipe 3.5 times, we'll need 3.5 times as much butter. So if we do 125 grams of butter multiplied by 3.5, we get 437.5, which is the answer to the question. In the second part of the question, we're told that Kian has 1.2 kilograms of butter, and we need to work out the maximum number of flapjacks that Kian can make. Let's first of all convert the 1.2 kilograms into grams. We can do this by multiplying 1.2 by 1000, which is 1200 grams. The recipe for 12 flapjacks uses 125 grams of butter, so we want to see how many times we could create that recipe until we run out of butter, considering that we have 1200 grams. We can do this by doing 1200 divided by 125. This gives you 9.6. This means we could repeat that recipe 9.6 times and then we wouldn't have any more butter. If we're going to do this recipe 9.6 times, we could create 12 flapjacks 9.6 times. So we do 12 times 9.6. This will give you 115.2. So we could create 115.2 flapjacks. But of course, flapjacks come in whole numbers. Nobody wants 0.2 of a flapjack, so the answer would be 115. In this question, we're told that angle ABC is the interior angle of a regular polygon with m sides, but then angle ABD is the interior angle of a regular polygon with n sides. You can see from the diagram we have three angles here, and since they're all around a point, they must add up to make 360. So let's add together all of the angles, so x plus 3 plus 33, and this must make 360. We can just solve this equation now. We've got x plus x, which is 2x, and 3 plus 33, which is 36. This equals 360. If we subtract 36 from both sides, on the left-hand side we'll just be left with 2x, and on the right-hand side 360 take 36 is 324. We can then divide both sides by 2, 2x divided by 2 is 1x, and 324 divided by 2 is 162. So we found that x is 162. So we can replace the x on that bottom angle with 162, and the x plus 3 must be 3 more than 162, so 165. So we've now found the angles ABC and ABD. So for the regular polygon with m sides, we know its interior angle is 165. We can also work out its exterior angle by subtracting this from 180, since the interior and exterior angles always add together to make 180. So the exterior angle for this polygon must be 15. For the regular polygon with n sides, the interior is 162, and we can also get the exterior by subtracting 162 from 180, which gives you 18. Now we want to work out the values of m and n, which is how many sides the polygons have. There's a formula to work out the number of sides of a regular polygon, which is 360 divided by the exterior angle. So to find the value of m, we can do 360 divided by its exterior angle, which is 15, and this will give you m equals 24. For the one with n sides, we do 360 divided by the exterior angle, which is 18, and this gives you n equals 20. So we now know the values of m and n. We've been asked to work out the value of m subtract n, so we do 24 subtract 20, which is 4. In this question, the number of bacteria is set to rise by 0.2% each day, and we need to show that after 1 year the number of bacteria will have more than doubled. If we're going to increase by 0.2% each day, we want to work out the multiplier for a 0.2% increase. So if we start with 100% and add 0.2%, we get 100.2%. We can turn this into a multiplier by dividing it by 100. So 100.2 divided by 100, which is 1.002. This means to increase by 0.2%, we multiply by 1.002. Now it's going to increase by 0.2% each day, but we're going to do this for 1 year, which has 365 days. So we're going to multiply by 1.002 365 times, which is the same as 1.002 to the power 365. Now if you type this into your calculator, you'll get this number here. So in this question, we would multiply the number of bacteria by 2.073568367. Now when you multiply a number by 2, it doubles, and this number's bigger than 2, so it must have more than doubled. So to finish this question, we just need to mention that this number is greater than 2. So the number will more than double. In this question, we're told that there are 868 ways of selecting one student from Class B and one student from Class C. To work out this 868, we must have multiplied the number of students in each of those classes together. In the question, we've been told the number of students in Class B is 28, but we don't know how many students are in Class C. That's been given as x. So if we multiply 28 by x, we get 868. So we could work out x by doing 868 divided by 28, which gives you 31. So the number of students in Class C must be 31. We are also told there are 700 ways of selecting one student from Class B and one student from Class D. In Class B there are 28, but in Class D there are y. So just like before, we're going to do 700 divided by 28, which gives us 25. So there are 25 students in Class D. In the question, we've been asked to work out the number of ways of selecting one student from each of the 4 classes. So we're going to multiply the number of students in each of the classes together. So it's 30 students from Class A, multiplied by 28 from Class B, multiplied by 31 from Class C, and multiplied by 25 from Class D. If you do this on your calculator, you'll get 651,000, which is the answer to the question. In this question, we need to show that 2 lines are perpendicular, We're going to do this by working out their gradients. For line L1, the gradient is easy to see because the equation is given in the form y equals mx plus c, so the gradient is just the number in front of the x here, which is 5. For the second equation though, we're going to need to rearrange it to get it into that form. We'll start by subtracting 2x from both sides. On the left hand side this will give us 10y, and on the right hand side 9 subtract 2x. Then we're going to divide both sides by 10. On the left hand side 10y divided by 10 is just 1y, and on the right hand side we'll do 9 divided by 10, which is 0.9, and then we have negative, and we need to do 2x divided by 10, which is 2/10 of x. We can simplify this negative 2 over 10 to negative 1 over 5, and we can now see the gradient is negative 1/5. To show two lines are perpendicular, their gradients must multiply together to give negative 1. So if we multiply 5 by negative 1/5, we do get negative 1. Therefore, these lines are perpendicular. In the first part of this question, we need to factorise fully. We're going to start by factorising out a 2. So we have 2 and then a bracket. Inside this bracket we would need c squared, since 2 times c squared is 2c squared, and also negative 9d squared, since 2 times negative 9d squared is negative 18d squared. Now some students will think that we fully factorised at this point, but there's actually one more factorisation we could do. If we look at the terms inside the brackets here, we have the difference of two squares, since c squared is a square and 9d squared is also a square. So we can write this as 2, and then we need to do the difference of two squares factorisation. To do this we square root the c squared, which is c, and we also square root the 9d squared, which is 3d. So the brackets will be c plus 3d and c subtract 3d. So this is the fully factorised form and the answer to the question. In the second part of the question we need to simplify fully. We're going to do this by factorising. On the top we can factorise out a 3 since 3 goes into 3 and 9, and we can also factorise out an x because there's an x in both of those terms. So it's 3x and then a bracket. Inside this bracket we would need x, since 3x times x is 3x squared, and plus 3, since 3x times 3 is 9x. On the bottom we can factorise out a 6 since there's a 6 in both of them, and also an x since there's an x in both of them. So we've got 6x and then a bracket. Inside this bracket we need x to get 6x squared, and we need y to get 6xy. Now that we've factorised it, we can cancel out any common factors. We can see we've got a common factor of x on the top and bottom, and we can also simplify the 3 over 6, which gives you 1 over 2. A bit like when you simplify 3 over 6 to give 1/2. We're now ready to write the answer. On the top of the fraction we have one lot of x plus 3, which is just x plus 3, and on the bottom we have two lots of x plus y. In the first part of this question we need to find the percentage of giraffes that have a height between 480 and 535 centimetres. Looking at the data we've been given, we can actually see 480 was the shortest, and 535 was the upper quartile. So we just need to know what percentage of data is in between the shortest and the upper quartile. When we split data into quartiles, 25% of the data lies between each of them. So there's 25% of data between the lowest and the lower quartile, 25% between the lower quartile and the median, and so on. We want to know the percentage of data between the lowest, because that was 480, and the upper quartile, because that was 535. Between these two values you can see there are 3 lots of 25%, which is 75%. So the answer is 75%. In the second part of the question we have a box plot and we need to find the mistake that Richard has made. Well, if you look at the data, the median is 502, but Richard's median here is not at 502. If we take a closer look at this and draw down from the median, this value here is not actually going to be 502. Halfway in between 500 and 520 is 510. This means there are 5 small squares in between 500 and 510, which means each of those squares will represent 2. So since we're 2 squares past 500, we're actually at 504. So we could say that Richard has plotted the median at 504 rather than 502. In this equation here, we're told that a divided by 5 is the same as b divided by 6. When equations are written in this form like this, it's easy to write down their ratios. This just means that a to b is in the ratio 5 to 6. When we look at this second equation here, it's not quite in the same form. We could rearrange it though to make it look like the other one. If we multiplied both sides by c, we'd cancel the c on the left hand side, so we'd just have b, and on the right hand side we'd have 4c over 9. If we then divide both sides by 4, we end up with b over 4, and on the right hand side the 4 would cancel, so we'd have c over 9. This now looks like the other one with the letters on the top, so we can write down the ratio of b to c is equal to 4 to 9. Now that we've written down both of these ratios, we want to combine them into one ratio for a to b to c. Notice that the letter b is in both of the ratios. In the first ratio, b is 6 parts, and in the second ratio, b is 4 parts. So we would like both of these numbers to be the same. The lowest common multiple of 6 and 4 is 12, so we're going to scale these ratios up so they both have a 12 where the b is. To do this then, we'd multiply the first ratio by 2. So a to b would be 2 lots of 5, which is 10, and 2 lots of 6, which is 12, as we required. In the second ratio, we'd multiply by 3. So we'd multiply 4 by 3, which is 12, as we required, and 9 by 3, which is 27. Now that we have 12 here in both of the locations for b, we can combine them into one ratio. So the ratio for a to b to c is 10 to 12 from the a to b ratio, and 12 to 27 for the b to c ratio. So it's 10 to 12 to 27. In this question, we need to work out an upper bound for m. We're going to begin by writing down the error intervals for all of the letters p, t, and r. We'll start with p, which is 870 to two significant figures. This means that p must be in between 865 and 875. Then for t, which is 500 to one significant figure, that must be in between 450 and 550. And finally, r is 0.03 to one significant figure, so this must be in between 0.025 and 0.035. Now if we look at the formula for m, it's the square root of p subtract t over r. So we're going to need to do the square root of some number subtract some number divide by another number. But we want to make m the upper bound, so we want it as big as possible. To make this as big as possible, we want to do the maximum number on the numerator here, but we want to divide by the minimum number here, since when you divide by a smaller number, you get a larger answer. Now the minimum one is quite easy because on the bottom of the fraction we just have r, and the lowest value for r is 0.025. On the top though, we need to be a bit careful. If we want to make p subtract t as big as possible, we want the biggest value for p, which is 875, but we would subtract the smallest possible value of t, since when you subtract a small number, you keep the answer as big as possible. So we would subtract 450. You then just type this into your calculator and you get this answer here. The question wants the answer to 6 significant figures, so it would be 130.384. In this question, we need to show that there's a solution between x equals 2 and x equals 3. To do this, we just substitute these values into this expression here. So we'll start with x equals 2, and it's x cubed, so we need to do 2 cubed, and then subtract x, so subtract 2, and then subtract 9. If you type this into your calculator, you'll get -3. Then we'll do exactly the same process for x equals 3. So 3 cubed, subtract 3, subtract 9, which gives you 15. Here we can observe a change of sign. Since the original equation was equal to 0, one of these is below 0 and one is above 0, we know that there must be at least one solution in between x equals 2 and x equals 3. So we can just write down that the change of sign shows there must be a solution between the values of x equals 2 and x equals 3. In the second part, we need to rearrange this equation to give this one. So let's start with the original equation, and we'll begin by adding x to both sides. On the left-hand side, this will cancel the negative x, so we're left with x cubed subtract 9. But on the right-hand side, we've got 0 plus x, which is x. Then we would add 9 to both sides. This will cancel the negative 9 on the left, so it's just x cubed now. And on the right-hand side, we have x, but then we add 9, so x plus 9. The final step is to cube root both sides. If you cube root x cubed, you get x. And to cube root the right-hand side, we just write the cube root of the right-hand side. This is the equation we were aiming to get to, so we finish the question. In the final part of this question, we're going to start with x0 equals 3 and use this iteration formula 3 times to find an estimate to the solution of the equation. To do this, we'll need to use a calculator. So we're going to substitute 3 into that equation, and then whatever we get from that, we'll substitute that number in, and whatever we get from that, we'll substitute that number in. So let's begin by typing in the first one, and we need to use the cube root symbol, so we'll press shift, and then cube root. And then we're going to replace the xm with a 3, and then plus 9. Then we press equals. So this gives us the value of x1. So let's write that down. And then we need to substitute that value back into the formula. So let's go back through and remove the 3 and replace it with the answer button. That will substitute that number back in. Then we press equals and we get the value of x2, which is this. Now to get the value of x3, we can just press the equals button again and we get this number. So x3 is this. Now that we've done it 3 times, we have our answer to the question. So we would just write down the most recent one we did, which is this one here. In the first part of this question, we need to work out fg of 1.5. This is a composite function, and to work it out, we can do g of 1.5 first, and then whatever we get from that, we put into the f function. So let's start with g of 1.5. To do this, we just substitute 1.5 into this function here. So we replace all of the x's with 1.5s. So it's going to be 1.5 subtract 1 over 5 subtract 2 lots of 1.5. If you type this into your calculator, you'll get 0.25. Now we need to substitute 0.25 into the f function, so that's f of 0.25. The f function is 80x squared, so we need to do 80 multiplied by 0.25 squared. If you type this into your calculator, you'll get 5, which is the answer to the question. For the second part of the question, we need to find an inverse function, g inverse of x. We're going to start by writing out the g function, but replacing the g of x with a y. So it's y equals x minus 1 over 5 minus 2x. We're then going to switch all of the y's to x's and all of the x to y's. So the y will turn into an x, and the x's on the right hand side will turn into y's. Now we need to make y the subject. We're going to start by multiplying both sides by this here. On the left hand side, that will give us x lots of 5 minus 2y, and on the right hand side, 5 minus 2y will cancel, so it's just y minus 1. Now let's expand out this bracket on the left hand side. X times 5 is 5x, and x times negative 2y is negative 2xy. And we'll leave the right hand side the same. Now we want to get all of the terms that involve a y on the same side, and all of the terms that don't involve a y on the other side. I'm going to get all of the terms that have a y on the right hand side, so I'm going to start by adding 2xy to both sides. If I add it to the left hand side, the negative 2xy will cancel, so I've just got 5x. If I add it to the right hand side, well I've got y minus 1, but now I've added 2xy. Let's move this up to the top so we have some more space. Now on the right hand side I have the terms involving y, but I also have this negative 1, so let's add 1 to both sides as well. If we add 1 to the left hand side, it's 5x plus 1, and if we add 1 to the right hand side, that negative 1 will cancel, so I've got y plus 2xy. I've now got all of the terms that don't involve y on the left, and all of the terms that do involve y on the right. I can leave the left hand side the same, but on the right hand side I can now factorise out the y. It will be y, and then inside the bracket I'll need 1 since y times 1 is y, and 2x since y times 2x is 2xy. I can then divide both sides by this bracket here. On the left hand side I'll have 5x plus 1 over that bracket, and on the right hand side that will cancel, so I'll just be left with y. I've now got y as the subject, and I can replace that y with g inverse of x. So the answer to the question is 5x plus 1 over 1 plus 2x. In this question, we need to solve an equation with some algebraic fractions. At the moment, you can see that these two fractions here have different denominators. We're going to make them the same by finding the lowest common multiple of these, which is actually just their product. So we're going to rewrite both of these fractions over 2x plus 3 times x minus 2. For the left fraction, the denominator has been multiplied by x minus 2, so we need to multiply the numerator by x minus 2 as well. On the right fraction, the denominator has been multiplied by 2x plus 3, so we multiply the numerator by 2x plus 3 as well. And all of this equals 1. Now that these two fractions have the same denominator, we can combine them into one fraction. We just need to add the numerators together. So it's 2 bracket x minus 2 add 3 bracket 2x plus 3. Now we can expand out those brackets. So we've got 2 times x, which is 2x, and 2 times negative 2, which is negative 4, and 3 times 2x, which is 6x, and 3 times 3, which is 9. Next we can simplify the numerator by collecting like terms. We've got 2x plus 6x, which is 8x, and negative 4 plus 9, which is 5. Next we're going to multiply both sides of the equation by the 2 brackets on the bottom of that fraction. On the left hand side, this means those brackets will cancel, so we've just got 8x plus 5. On the right hand side, we'll multiply 1 by both of those brackets, which is just those brackets. Now we'll expand out the double bracket. So on the right hand side, we've got 2x times x, which is 2x squared, 2x times negative 2, negative 4x, 3 times x, which is 3x, and 3 times negative 2, which is negative 6. We can simplify on the right hand side. We've got 2x squared, negative 4x plus 3x is negative 1x, and then subtract 6. Here we have a quadratic equation to solve. To solve it, we want one of the sides to be equal to 0. So let's get all of the terms on the right hand side. To do this, we'll subtract 8x and 5 from both sides. So the left hand side will now be 0. On the right hand side, we've got 2x squared, but we said we're going to subtract 8x, so we've got negative 1x subtract 8x, which is negative 9x, and we're also going to subtract 5, so negative 6 subtract 5 is negative 11. This quadratic will factorise, so the left hand side will be 0, and the right hand side will be 2x minus 11, x plus 1. This isn't the most difficult factorisation to do, since the only way to get 2x squared is multiply 2x by x, and the only way to get 11 is multiply 11 by 1. So you should be able to spot this factorisation quite quickly. This leads us to two solutions. Either the first bracket equals 0, so 2x minus 11 equals 0, or the second bracket equals 0, so x plus 1 equals 0. For the one on the left, we can add 11 to both sides, and we get 2x equals 11, and divide both sides by 2, and we get the solution x equals 5.5. For the right one, we just subtract 1 from both sides, and we get x equals negative 1. So these are your two solutions and the answer to the question. In this question, we're told the ratio of these three angles, which is 3 to 5 to 12. The angles given in the ratio are these ones here. Since the ratio is 3 to 5 to 12, we could call the smallest one 3x, the next one 5x, and the next one 12x. There are many different ways of approaching this question. I'm going to focus on this pentagon here. Now we've actually got almost all of the angles of this pentagon marked on. The ones that we're missing are these two here. Now we don't know how big these angles are, but we do know one important thing about them. Since they're opposite angles in a cyclic quadrilateral, they must add together to give 180 degrees. Next we're going to find the sum of the interior angles of a pentagon, using this formula here. The number of sides subtract 2 times 180. Since a pentagon has 5 sides, we do 5 subtract 2 times 180, which is 540. This means all of the angles inside that pentagon must add up to give 540. So we could add together all of the angles we have, which is 2 lots of 90 degrees for the two right angles, then all of the algebraic angles, so 3x, 5x, and 12x, and then we've got these two green angles, which we don't know how big they are, but we do know that they contribute 180 degrees. All of these angles must add up to make 540. So we just need to solve this equation to find the value of x. If we add together 3x, 5x, and 12x, we get 20x, and if we add 90, 90, and 180, we get 360. And this must equal 540. If we subtract 360 from both sides, on the left we'll get 20x, and on the right we'll get 180. Then divide both sides by 20, and we'll get x is equal to 9. In this question we were asked to work out the size of angle AFE, which we marked here as 12x. Since x is 9, this angle must be 12 lots of 9, and 12 lots of 9 is 108 degrees, and the answer to the question. In this question, we're given an iterative formula. This formula allows us to work out the distance that a race car has travelled depending on how far it had travelled 1 second earlier. We're told at the start of the question that the car begins stationary and then accelerates from a start line. So the value of d0 must be 0, since after 0 seconds the car hasn't travelled anywhere. We can then use the formula to work out the next values. So d1 will be k, which is some constant, multiplied by the previous distance value, which is d0, and then plus 10. Now we know that d0 was equal to 0, so we've got k times 0 plus 10, but k times 0 is just 0, so this is just 10. Then we can work out d2 by doing k multiplied by the previous distance, which was d1, and then plus 10. But we said that d1 was 10, so we've got k times 10 plus 10, or 10k plus 10. Now we actually know the value of d2 because it's been given in the question. We're told that it's travelled 23 meters in the first 2 seconds. So we can replace d2 with 23. We've now got an equation to solve to find the value of k. If we subtract 10 from both sides, we get 13 equals 10k, and then divide both sides by 10. You'll find that k is 1.3. Now that we know the value of k, we can continue to do this to find the next values. So for d3, we do k, which we now know is 1.3, multiplied by d2, which was 23, and then plus 10. If you do this with your calculator, you'll find that d3 is equal to this. Then we can find d4 by doing 1.3 times d3, which was 39.9 plus 10, which gives you 61.87. And we can also get d5 by doing 1.3 times d4, which was 61.87, and then plus 10. And if you do this with your calculator, you'll find that d5 is 90.431. Now I'm going to stop at d5 because the question asks us to work out the average speed of the race car during the first 5 seconds. So in the first 5 seconds, the car travels 90.431 meters. That's the distance, and the time is 5 seconds, so we can find the average speed by doing distance divided by time. So 90.431 divided by the 5 seconds, which gives you an average speed of 18.0862, and that's the answer to the question. In this question, we need to work out the area of triangle ADC. We've been given some information in this question, so let's mark that onto the diagram first. We're told that AB is 18, BD is 8, and angle ABD is 15 degrees, so that's this one here. We're going to start by looking at this triangle here, and we want to work out the length of AD. I'm going to label the length AD as lowercase a, which would mean the angle opposite it, which is the 15, is capital A. The remaining 2 sides will be lowercase b and c, and it doesn't matter which way we label these, I'm going to make the 18b and the 8c. I'm then going to use the cosine rule to find the value of a. So this is the cosine rule, and I'll substitute in any values I know. So we have a squared equals b squared, so that's 18 squared, plus c squared, so that's 8 squared, minus 2bc, so minus 2 times 18 times 8, and then times cos of capital A, so cos of 15. So we have a squared equals, and this entire right-hand side could be put into your calculator, and it will give you this number here. To find the value of a then, we can just square root both sides. So we'll get a equals the square root of this number, which gives you this number here. So we've now found the length of DC, so let's replace the a on the diagram with 10.4 and so on. Next I'm going to work out the angle DAB, which is the one in the bottom left here. To do this, I'm going to relabel the triangle. I'll label the angle I'm trying to find as capital A, the side opposite as lowercase a, and then the angle at the top capital B, and the side opposite that lowercase b. So I can use the sine rule now to find the value of capital A. I have sine of A over A equals sine of B over B. I know lowercase a, that's 8. I know lowercase b, that's the number we worked out a moment ago, 10.4 and so on, and capital B was given in the question, that's 15. If we multiply both sides of this equation by 8, we get sine of A equals 8 sine 15 over 10.4 and so on. We can now type the right-hand side into the calculator, and you must be really careful and make sure you use the full number for the 10.47918709. This will give you sine of A equals this number here. We can then find the value of capital A by doing inverse sine of that number, which gives you the answer of 11.39 and so on. So let's update our diagram. We now know the value of this angle here. Now in the question we were told that this triangle was an equilateral triangle, which means all of its interior angles are 60 degrees. So we can find this angle here that I've marked in green by doing 60 take away the red angle, which will give you this value here, since both of those angles must add together to give 60 degrees. Now because this triangle is equilateral, all of the sides are also the same length. So AB was 18, so AC is also 18. We can now focus on the triangle ADC, which we're trying to find the area of. We can label the 10.4 and so on as lowercase a, the side from A to C, which is 18, as lowercase b, and the angle in between them as capital C, and then use the formula half AB sine C. So the area is a half times A times B times sine of C. So we just need to substitute these numbers in. So it's 1/2 times A, which was the 10.4 and so on, times B, which is 18, and times sine of capital C, which was the 48.6 and so on. So you now want to type this into your calculator, but once again, for the 10.4 and so on, and the 48.6 and so on, you want to use the full numbers. If you do this, you'll end up with this answer here. The question says to give your answer to 3 significant figures, so we'd round this off to 70.7, and that's the answer to the question. For some of you, this may be the last video of mine that you ever watch, so I just want to say thank you for supporting my channel and wish you the best of luck for your final paper next week. If you are going to do A-level maths next year though, you may be interested to know that I do plan to make A-level content in the future. Finally, it would help me out a lot if you could like this video and leave a comment. And once again, good luck for your final exam next week.